First, third, and fourth terms of an arithmetic progression are u1, u3, and u4 respectively, where they're given in terms of trig, theta's between pi over 2 and pi. Determine the exact value of theta. So we know that, well, this term would be a, this would be a plus 2d, skips to a plus d, that would be u2, and this is a plus 3d. So when we subtract, we do u4 minus u3, we're going to get d. So I'm going to write down that as an equation. D will equal 7 over 2 sine theta minus root 3 cos theta. The minus makes it a plus. So that's one equation I can write down. And I can also look at u1 and u3. If I subtract them, I'm going to get 2d. That will be minus root 3 cos theta minus 2 sine theta. And I can take the top one. Actually, what I'm just going to do is replace this by all of this. I mean, I could times the top one by 2, but let's just go with it. I'm going to replace it, which means I am going to be timesing by 2. I'm going to get 7 sine theta plus 2 root 3 cos theta, and that's going to equal minus root 3 cos theta minus 2 sine theta. Adds 2 sine theta to both sides. I'm going to get 9 sine. I'm now solving this, by the way. And when you just have sine and coses like this, yeah, the aim is to get tan. So it's get sine on one side, and then let's get cos on the other side. I'm going to get minus 3 root 3 cos theta. Divide through by cos theta, giving me sine over cos, or tan. Divide the both sides by 9, which gives me minus 3 root 3 over 9, which actually is minus root 3 over 3. Okay, and now we can solve this. Remember that theta is between pi over 2 and pi. It's the only thing to be aware of. We're working in radians. You might know this exact trig value because 1 over root 3 actually gives you 30 degrees, which is pi over 6. So we're going to get minus pi over 6 here. But sorry, that's not me showing off. That's just, it's one, if you work with exact values a lot, then you kind of end up noticing them. So minus pi over 6. Now, that is not in the range that we're interested in. So you've got a couple of ideas that you can do. You can either think about your tan graph. We don't even need it really. Basically, it repeats. We found this one here. It repeats every 180 degrees or pi. So I just need to add on pi radians. Or with your cast diagram, we've got a negative one to get the next one. So we've got that one there. So I need to, which is the same as that one there. So I need to do pi minus pi over 6 or minus pi over 6 plus pi. Okay, we're going to reject this one, it's outside the range, and we've found our value of theta, 5 pi over 6. Right, hence determine the sum of the first 100 terms. Well, let's sub back in. I'm going to work out what u1 is. It's going to be 2 sine 5 pi over 6. Which is just 1. So that's my value of a. Remember, this is an arithmetic sequence. We could even check our answer by finding what u3 and u4 are. And I think that is a good idea, to be honest. I know the main aim is to find d, which we'll do in a second. So minus root 3 cos 5 pi over 6 is 3 over 2. So I've gone up by a half, but that's between two terms. So it looks like d is going to be 0.25. Let's just check. This should be 1.75 when I work it out. 7 over 2 times sine 5 pi over 6. And it is 7 over 4 or 1.75. So I can see that this would be 5 over 4, yeah, 1, 1.25, 1.5, 1.75. D is going to equal a quarter. And if you put it back into one of the earlier ones, like this here, like essentially it's the same thing as what I've just done. You'd be just subtracting the terms. 7 over 4 minus 3 over 2 gives a quarter. So that means if I want to find this, it's actually just the sum of 100 for an arithmetic series. And this is in the formula book. Sn is going to be half n times 2a plus n minus 1d. So for us, we're going to get a half times 100 multiplied by 2a, which is just 2, plus 99 times a quarter. 50, 99 divided by 4 plus 2. 50 times 107 over 4. Gives a final answer of 2. Do I write it the decimal? 1337.5. Fraction's okay as well. Okay.